Welcome back to Getting Started with C# and Unity. In our last episode, we expanded our playing area and made a little boss dungeon, and then we programmed our little boss here to follow us around, and if we get touched by him, it'll reload the level. In this episode, we're going to find a way to defend ourselves by shooting projectiles. We're going to kill the boss, have him drop a key, and use this key to open this locked door. Alright, so let's get started. So I'm going to start with making our player shoot projectiles first, mainly because that's freaking awesome and it's fun. So let's go ahead and explore how to make a prefab in Unity that we can spawn. Alright, so go ahead, anywhere in your game world, doesn't matter, go to Game Object, create 3D Object, and you can use any shape you want, but I prefer sphere for projectiles, just because they're, really bouncy. Well, you can make them bouncy, but and that seems about right. You want it somewhat small, or else you're going to be shooting gigantuan spheres, unless that's what you want, because it's your game. But I'm going to keep it nice and small. Alright, that works for me. I'm going to make a new material for it, just so it stands out a little bit. Let's call it Proj for projectile. I'm going to choose a nice lime green. Drag that on projectile. Perfect. Go ahead and rename this sphere to projectile, or whatever you want, laser, phaser, doesn't matter. Okay, that's all good. We're going to need to add a rigid body component to this. Go ahead and add a rigid body. There we go. Don't have to use constraints. Gravity's okay, everything's alright. I want to do a little something fun here and make this a bouncy ball. So you're just, shooting bouncy balls at the enemy and killing him with it. So I'm going to go ahead and make a new physics material for that. So I'm just going to right click in my assets, create, and at the bottom here you're going to say physics material. I'm going to call it bouncy. And right here in the inspector, when you have that physics material selected, you can select bounciness. I'm just going to put 1 for now. Anything higher than that is a little overkill, but that's perfect for me. And then I'm going to go back to our sphere and drag that bouncy onto the rigid body. Actually, I'm sorry, the collider on the material slot. So now we should have a bouncy ball that we can see here. Boing, boing, boing. Alright, perfect. So now, how do we get our player to shoot that thing? Well, first we're going to need to make it a prefab. So I'm going to go ahead and make a new folder called prefabs. And you can just take this projectile and just drag it into here. Now you have a prefab of it. That means we can make an infinite amount exact copies of this little projectile. Perfect. And you can go ahead and delete that from the game world since we already have a prefab. So we're going to need to go back to our player script here. I'm going to open up Mono. And you should see it in the corner here, player controller, or up here. So once that's open, we're going to need to check for a keystroke, which will probably be our left mouse button, and we're also going to need a new game object variable to store our prefab in. So let's get started with the prefab part. We're going to need to make this public again, so public game object with a capital G. And let's just call this Proj for projectile, and then you can hit a semicolon right there. Now go ahead and go back to Unity, select your player. Now you should see a little space that says none, game object, and it should be named Proj. Drag your prefab from the little asset bank here into that slot. Now you have reference to your prefab, and you can spawn as many as you want. How awesome! You can also have a public variable, like force or something. So you say public float projectile force. I'm gonna set that to 1.0f. Actually, no. Let's go fun. Let's go 1,000. Alright, perfect. Now, we're gonna need to check for input here. So, basically the same thing as input.getKey. There's a slight difference that we don't want getKey because that's like checking constantly. Instead, we want if input.getKey down. That's important, because if we just use getKey, you would shoot an infinite amount of little bouncy balls extremely quickly. and you say key code. Now this is a little bit confusing because it doesn't say mouse left, right, blah, 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 blah. You want to say key code dot mouse 0. Mouse 0 refers to the left mouse button. Mouse 1, I think, is the right. It might be the middle. And mouse 2 should be the right mouse button, but I'm not sure. It might be the middle. These two I'm not sure about, but definitely for sure, left mouse button is 0, and that's all we need. So go ahead and put your curly brackets there. Now I'm actually going to make a function for this. This is actually an important part of C#, important part of any object-oriented programming language anyway. We're going to call this function, and it's going to instantiate our little prefab there and shoot it with a rigid body push. So let's go ahead and make our new function. It's going to be of return type void. So void, I'm just going to call it fire. It's common practice to begin your functions with a capital letter, but it doesn't exactly matter. It's just, you know, programming etiquette. It'll accept no overrides. All right, so that's all we need for now, fire. And right in this if statement, we're going to call that function. So we're going to say fire, and it accepts no overrides. So we can just put those parentheses there. Perfect. All right, so if I click this mouse button, nothing will happen because all it's doing is calling a blank function. This is where we can put our little code block to repeat over and over again. So what we're going to do is first, we need to spawn our projectile in the game world. Now this is going to get a little bit complicated, but bear with me. First, we need to make a temporary variable in line. So we're going to start with a game object with a capital G. I'm just going to call it P since it's a temporary variable. We don't need it for very long because we know what it is. Equals instantiate, and that essentially means spawn something in game world. And this is a function, so go ahead and open parentheses. Now it needs three things here. It needs the object instantiate, so that's our game object, that's our projectile. And it's going to need a transform position, so a vector 3, so where do I spawn it? And it's going to need a rotation. It's like, what rotation do you want it to spawn as? So first things first, we're going to say proj, so spawn our projectile. Where do you want to spawn it? Well, I want to spawn it preferably where my player is. So since this is the player control script, we can just say game object, no, with a lowercase, like that. For some reason it keeps changing it, but we don't want that. There we go. Dot transform dot position. That refers to us. And then this is a big word, quaternion dot identity. Quaternions are very nasty, but quaternion dot identity is useful because all this means, all these big words, it just means to spawn how you are. Don't put any rotation, just normal spawn, 0, 0, 0. And that's all we need. So this line right here will spawn our projectile. However, actually it looks like we have a little error here. Let's double click that. Let's see what we have here. Oh, okay. There's an important part here. This is instantiating an object, and this is expecting a game object. So what we can do is something called typecasting. So at the very end, before your semicolon, just say as capital game object. So that's just going to let this know that this object is a game object. Don't worry about it, Unity. Chill, man, chill. All right, cool. So anyway, like I was saying, if I click here, you should see a little bouncy ball spawn, but it's not exactly shooting. It's just kind of, yeah, that's no fun. So to make it shoot, we need to push it a little bit. So since we have this P here, since we've defined it as P, instantiated it, we have immediate reference to it. So we can say P dot rigid body dot add force. Ooh, fancy. Now it's going to be looking for a vector 3, and all this vector 3 is a direction. So say vector 3 dot forward multiplied by our projectile force. There we go. Perfect. And we don't need a time.delta time here because this is not a time sensitive operation. Okay, so this works all fine and dandy. However, there's going to be interference with our player's collider and the collider on these projectiles. So there's one slightly more kind of complex thing that we need to do, but it's not too bad. So if we go back to the engine and we look at our player, you'll notice this thing that says layer. We want to make a couple new layers here. So go ahead and click that and hit add layer. Put our player under the player layer. That's awesome. And then let's make another one for projectile. Proj. Go back to your player and label him as a player. And yeah, go ahead and change children. Now in your assets here, go back to your prefabs projectile and go ahead and name or label him under the layer of Proj. We're also going to want a projectile tag because we're eventually going to shoot our enemy with it. So go ahead and add a new tag. Just call it Projian. Make sure to add it. Perfect. So this is important because this is how your game will work physically. Go ahead and go to Edit, Project Settings, Physics. Now you're going to see this little matrix right here that looks a little complex, but all it is a matrix describing how things will interact with each other physically. So if we look for player proj, if we uncheck that, that means projectiles will stop interacting with players. Make sure to uncheck player proj that matches up on the matrix, or else you're going to get colliding projectiles. So now our firing script should work perfectly. Pew, pew, pew. Yeah, all right. Cool. And you notice how it's going right through the player and not interfering whatsoever. All right, cool. So you notice we have kind of a buildup of bouncy balls here, and we want to get rid of them over time, or else we're going to get some performance issues. So we can fix that easily since we already have reference to them. We can say destroy P, and this takes two arguments. You can just put P and it'll destroy it immediately, or you can say P, comma, and see how it says float T. Let's say 5.0F. Now this will destroy P after 5 seconds. So if we fire one, look at it, eventually, yep, there it goes, disappeared. Perfect. Now, any game that involves shooting projectiles would not be complete without pew pew noise. I plan to have only Unity featured in this tutorial. However, there is an awesome free website that I use all the time called bfxr.net, and basically all it is a little synthesizer that makes public domain sound effects, and this is perfect for making little sound effects for a game like this. So we want a little laser shoot sound, so we can hit laser shoot. That sounds perfect. You can hit export wave. I'm just going to put it on our desktop, laser shoot, perfect. I'm going to go ahead and import that. I'm going to make a new folder in here just called sounds. And you can import stuff by dragging in the wave file. And now we have it. Sweet. So how do we play it? Well, first we're going to need to go to the player, add a component, and that component is going to be audio source. This is important. And then you can just leave that. In our script, we're going to need a new variable. You're going to say public audio clip. Let's just call it Pew. Why not? So in our fire script, we're going to say audio, lowercase, dot play one shot, pew. And then we can take this laser shoot sound and drag it into our public variable. So now every time we shoot, makes a little pew sound. Perfect. All right. So let's go ahead and things, okay? All right, so we have made a player that shoots projectiles successfully and makes a pew noise. In the next episode, we're going to worry about destroying our little enemy here, having him drop a key, and we'll open that door with the key he drops. So I'll see you next episode. Thanks for watching.